Imagine cutting the time it takes to reach Mars by nearly half. A journey that once took up to 300 days could soon be done in just 100, thanks to a groundbreaking advancement in space propulsion coming out of the United States in 2025. At the heart of this innovation is nuclear thermal propulsion, or NTP, a system that uses a nuclear reactor to heat liquid hydrogen, then expels it at high speeds to generate thrust. It's vastly more efficient than traditional chemical rockets, and it's now one step closer to reality. This year, scientists at the Oak Ridge National Laboratory and Ohio State University achieved a critical milestone. For the first time, they tested advanced nuclear rocket fuel coatings at a blistering 3,992 degrees Fahrenheit or 2,200 degrees Celsius. This testing simulates the intense environment inside a real NTP engine, one that might one day carry humans to the Red Planet. The test was conducted using a remarkable piece of technology called INSET 2.0, the In-Pile Steady-State Extreme Temperature Test Bed. It's the only test bed in the world that can rapidly heat nuclear fuel surrogates inside a research reactor, and its modular design means it can be used in any facility with a port over 8 inches. But the real star of this experiment is the zirconium carbide coating developed by ORNL. Nuclear engines face intense challenges, from high heat to hydrogen corrosion to radiation damage. Zirconium carbide acts as a powerful barrier, protecting the fuel without compromising performance. This is critical for long-duration missions where safety and stability are everything. 4 coated samples were placed into the INSET furnace, undergoing repeated heat cycles while being irradiated over 2 days. This is not just a lab test, it's a near-real simulation of the harsh conditions inside a nuclear thermal rocket engine. And the results from the post-irradiation analysis at ORNL will be crucial for certifying these materials for real-world use. To understand how big this is, we need to look back. In the 1960s and 70s, NASA's NERVA program laid the foundation for NTP. They built and fired engines on Earth, proving the concept worked. But the program was shelved in 1973 due to political shifts and budget cuts. For decades, nuclear propulsion was considered too risky, too expensive, too far-fetched. Meanwhile, Russia developed the RD-0410 in the 1980s, a working nuclear rocket engine tested on the ground. Yet, like NERVA, it never reached space. China has expressed interest in nuclear propulsion as well, but detailed progress remains largely unknown. What makes this 2025 test so different is the combination of modern materials, science, experimental testing, and AI-driven modeling. For the first time, we are not just theorizing, we are building, testing, and preparing to fly. This work is directly tied to the DARPA NASA Draco program, which plans to launch a demonstration NTP engine into orbit by 2027. This would be the first nuclear rocket flight in human history, a game changer for Mars missions, cislunar transport, and long-term space exploration. Why does this matter? Because every day we cut off the trip to Mars, we reduce risks, radiation exposure, psychological stress, mission costs. Nuclear propulsion makes interplanetary travel safer, faster, and more feasible. And beyond science, there's strategy. The US isn't just investing in faster Mars trips, it's laying the foundation for sustained space leadership. With modular test beds like INSET and protective fuel coatings like zirconium carbide, the US now leads in practical, near-term nuclear propulsion readiness. This test is not just a technological success, it's a historical turning point. From the ashes of NERVA through Cold War competition to the frontiers of 21st century exploration, nuclear propulsion is finally coming of age. But this journey doesn't end here, it's just beginning. If you're as fascinated by the future of space travel as we are, hit that like button, subscribe to stay updated on every leap toward Mars and beyond, and share this video with someone who dreams of the stars.